One purple compound controls the entire D block chapter. The high weightage topic of D block chapter we are going to discuss in this video. Hello students, let us start. Key points about KMnO₄ here. KMnO₄ potassium permanganate splits like this: K plus MnO₄ minus permanganate ion. We call it as permanganate ion MnO₄ minus. MnO₂ pyrolusite common name. We can prepare MnO₄ minus or KMnO₄ minus by using pyrolusite reaction with KOH O2, which gives MnO₄ minus and MnO₂ upon disproportionation of potassium manganate. K2MnO₄ is potassium manganate, which undergoes disproportionation to form MnO₄ minus MnO₂. What is the disproportionation? Same element undergoes both oxidation and reduction. Another method to prepare KMnO₄, electrolysis of K2MnO₄. Remember, K2MnO₄ is potassium manganate. KMnO₄ is potassium permanganate. K2MnO₄ is potassium manganate. Okay. And then at anode, K2MnO₄ we know MnO₄ minus 2 undergoes reaction at anode. So at anode, anion move towards anode, that is positive electrode, undergoes oxidation to form MnO₄ minus permanganate ion. So here it is manganate ion, here it is permanganate ion. You specify here it is manganate ion. So manganate as well as permanganate or potassium permanganate, if you show along with potassium, permanganate ion. Okay. Another method here, KMnO₄ react with Cl2 to form KMnO₄, or K2MnO₄ react with Cl2 to form KMnO₄. With Cl2 also you can prepare. KMnO₄ with ozone combination also prepare KMnO₄. So see methods here. MnO₂ used to prepare MnO₄ minus. Electrolysis of K2MnO₄ gives MnO₄ minus. K2MnO₄ reaction with Cl2 gives KMnO₄. K2MnO₄ reaction with ozone also gives KMnO₄. Remember, the compound is purple in color. KMnO₄, that is purple in color. Properties of KMnO₄. Action of heat, KMnO₄ purple in color. So K2MnO₄ is potassium manganate green in color, MnO₂ brown. So whenever it KMnO₄ heated, K2MnO₄, MnO₂ form, which is a further heating or further decomposition gives K2MnO₄. Action of H2SO4, important question. So here KMnO₄ with cold and concentrated H2SO4 gives MnO₂ green oily liquid plus, which is on decomposition gives MnO₂ and O2. So green oily liquid is here MnO₂, which is formed after reaction with H2SO4 concentrated cold. If it is hot and concentrated, H2SO4 gives MnSO4 dry when it is white, when it is dry, pink when it is moist, that is wet. KMnO₄ is strong oxidizing agent. KMnO₄ undergoes reduction as it is strong oxidizing agent. So reduction, how it undergoes? If we kept in basic medium, it is converted into MnO₄ minus 2. MnO₄ minus 2. Here N factor is 1. Equivalent mass of MnO₄, how we calculate? Molar mass by N factor. If molar mass of MnO₄ is M, N factor is 1. So equivalent mass of KMnO₄ in basic medium, it is M by 1. KMnO₄ if kept in neutral medium, it gives MnO₂. These products you have to remember. Products in different medium. MnO₂, change in oxidation number N factor 3 here. E is equal to M by 3, molar mass by 3, that is E is equivalent mass. KMnO₄ kept in acidic medium, here it gives change in oxidation number N factor 5, so M by 5 is equivalent mass. Examples you see where MnO₄ acting as oxidizing agent. So it can convert I minus into IO3 minus, where in basic medium. Basic medium, MnO₄ minus can oxidize Mn plus 2, or you can say come proportionation reaction here. Same element from different oxidation states, like you can say here plus 5 plus 2 convert into same oxidation state, that is plus 4. Even this reaction you have to remember, come proportionation of MnO₄ minus. Even MnO₄ minus can oxidize I minus in acidic medium into I2. So MnO₄ is oxidizing agent here, MnO₄, so which can oxidize I minus into I2. Even it can oxidize NO2 minus into NO3 minus. So here MnO₄ is acting as oxidizing agent. Even oxalate, C2O4 minus 2, which is oxalate. So oxalate ion upon reaction with MnO₄ gives CO2 ion here. Okay, that is oxalate ion also oxidized by MnO4 to CO2. Here observe one note, important statements I gave under note. KMnO4 is used as self-indicator in titration. Self-indicator already it is colored, so it is used as self-indicator. KMnO4 is not used as primary standard. Primary standard meaning solution of known concentration. We know in titrations we use one solution whose concentration already known to us, by using which we calculate other concentration. So KMnO4 is not used as primary standard as it is photosensitive, meaning whenever it is allowed exposed to light, readily decomposed to form MnO2 and becomes impure. Once if impurity is formed, you will get errors in measurement during titration. So here such photosensitive compounds cannot be used as primary standard. Primary standard is one solution whose concentration already known to us, by using which we calculate other concentration during titration. 1% dilute alkaline aqueous solution of KMnO4 referred as Bayer's reagent. Bayer's reagent used to find unsaturation of the compound. Like double bonded, triple bonded compounds, whenever added to Bayer's reagent becomes colorless. Actually, it is purple in color. So the purple color disappear whenever double bonded compound, triple bonded compound added to this particular compound due to addition reaction. That will be studied in detail even in organic chemistry. So Bayer's reagent, alkaline aqueous solution of KMnO4, which is used to find unsaturation of the compound. If any double bond, triple bonded compounds added to this particular compound, solution becomes colorless. KMnO4 becomes colorless. Based on this colorless nature, you can confirm that the given compound contains unsaturation. But here remember benzene, CH3COOH, FeCl3, CO2, 3O3 minus 2. These three already in most oxidized form. Because iron is plus 3 here, carbon is plus 4, carboxylic acid is most oxidized form. So cannot decolorize KMnO4, meaning cannot undergo further oxidation. As KMnO4 acting as oxidizing agent, they can oxidize unsaturated compounds. But however, these are not unsaturated, but chance of oxidation, even few compounds, if any chance of oxidation, even they can be oxidized by KMnO4. But here these three compounds cannot be oxidized or cannot decolorize KMnO4 because of most oxidized form. Carbon plus 4, that is highest state, iron plus 3, highest state, acetic acid is most oxidized form, that is carboxylic acid. Even benzene cannot decolorize KMnO4 because due to resonance, these double bonds cannot participate in reaction with Bayer's reagent. Okay, next. See some important reactions here with Fe plus 3, ferric ion. Whenever ferric ion react with ferricyanide, brown solution is formed. Colors you have to remember. Whenever ferric ion react with potassium sulfocyanide, red solution is formed. Ferric ion react with ferrocyanide solution, Prussian blue solution is formed. Fe plus 2 react with ferricyanide to form Turnbull's blue, that is compound, common name. Color also even Turnbull's blue color. Potassium sulfocyanide react with ferrous ion, blood red solution is formed. Ferrocyanide, if it is reacting, pale blue precipitate is formed. These reactions are respect to colors you have to remember. FeCl3, FeCl2 exist in dimer form. Dimer meaning combination of two units. Rinman's green is pigment used in paints, which is zinc cobalt oxide, which is found by zinc oxide and cobalt oxide. Ammonical silver nitrate is Tollens reagent. Tollens reagent can oxidize aldehydes into COOH, carboxylic acid. Like for example, aldehyde, Tollens reagent is Ag+. From Tollens reagent, we are getting this. From Tollens reagent, that is Ag+, we are getting Tr. When it is oxidizing aldehyde, it forms carboxylic acid. Itself undergoes reduction to form silvery grey PPT. And then CuCl2H2O on heating gives CuO, Cu2Cl2, that is reduction is happening, plus 2 became plus 1, which is on further decomposition gives Cl2HCl. Reactions you have to remember, these are most important and repeatedly asked questions in JEE Mains and Advanced. CuCl2 used as catalyst in Decons process. Decons process, it is used as catalyst. MnO4 minus 2, MnO4 minus 2, MnO4 minus. We know here MnO4 minus 2 is manganate ion. It is manganate ion. Here it is permanganate ion. manganate and permanganate ion. Okay, so here already we specified, no need to write again. Manganate ion, permanganate ion. MnO4 minus to structure like this, tetrahedral. Here also structure like this, MnO4 minus tetrahedral. The charge is +6, manganese charge at +7. Green in color, purple in color. Tetrahedral, tetrahedral. Paramagnetic in nature, meaning unpaired electrons present in it. Diamagnetic, no unpaired electron. D3s hybridization, D3s hybridization. In 3D series, copper has positive reduction potential. Only one element in 3D series having positive charge, positive reduction potential, that is Cu plus 2 to Cu is reduction, which is plus 0.34. Okay, why it is having positive reduction potential? Because Cu plus 2 Cu, if we convert, D10 configuration you will get here. That's why it is more stable. That's why it is positive. Mn2O7 structure, it is first of all covalent oxide, it is acidic oxide. Structure you can see here, tetrahedral unit, one more tetrahedral unit along with this oxygen. So there is MnO-Mn bridge, one bridge in between this. Okay, you see now JEE Mains 2026, 24th January shift 2 question here. Based on X is an oxoanion of the lightest element of group 7. The element is in +6 oxidation state. X, the color of potassium salt of X is. So they are asking about color of potassium salt of X. Once you read question everyone properly. 24th January shift 2 question. Okay, let us see. So here question, if you see the lightest element of group 7 it is. So here we know lightest element of group 7, that is transition elements if you consider. So with respect to this, observe, so lightest element of group 7, that is manganese. Lightest element meaning in a group, 7th group is that manganese group, below radius atomic weight increases. So group 7, so first element, that is manganese it is, where manganese is in +7 state. What they mentioned, oxoanion of the lightest element of group 7 it is. Okay, the periodic table, the metal is in +6 state. In X, the color of potassium salt of X is purple, orange, yellow and green. Okay, so here +6 they mention, not +7. So see now, here observe it, +6 it is green in color, KMnO4 -2, +7 that is purple in color, MnO4 minus. So with this information, what we can conclude here, first of all it is manganese, no doubt, right? So hence if it is MnO4 -2 and MnO4 minus, here we know manganese is in +6 state. Here manganese is in +7 state. They mention +6 state, right? So now potassium salt, you can write it as K2MnO4. K2MnO4 potassium manganate, which is green in color. So according to options, green color is correct here. Answer K2MnO4 is the compound, which is we know purple in color. MnO4 minus at +7 it is state. Okay, answer is green. Next question. JEE Mains 2026, 28 January shift 2 it is. So different statements given. Observe the statements everyone. Consider the following statements about manganate and permanganate ions. Identify the correct statements. Geometry of both manganate permanganate ions is tetrahedral. Yes, just now we studied. Here you can see tetrahedral. Next. Oxidation states of manganese in manganate and permanganate ions are +7, +6 respectively. So manganate +6, permanganate +7. But what they mentioned here? So they mentioned here oxidation state of manganese in manganate is +7 they mentioned. Actually it should be +6, right? So this should be, first is correct, second should be incorrect. They gave opposite. +6 for manganate, +7 for permanganate. Next statement. Oxidation of manganese salt by peroxodisulfate gives manganate ion as final product. Observe. Third statement. Oxidation of Mn+2 by peroxodisulfate. See a third statement you see here now. Mn+2 peroxide disulfate or the Marshall acid ion, it is H2O4 S8 H2O8 minus 2 gives permanganate ion. It gives permanganate ion, but they mentioned here it as manganate ion. Here you will get permanganate ion, not manganate ion. Okay, hence the statement is false here. H2O8 reaction with Mn+2 gives manganate ion, it's not permanganate. Okay, next, the manganate ion is paramagnetic and permanganate ion is diamagnetic. So manganate ion is paramagnetic, permanganate ion is diamagnetic. So it is correct only. Just now we studied above. Acidified permanganate ion reduces oxalate, nitrite and iodide ions. E is false, it's not reduces, it's oxidizes. Oxidizes oxalate, nitrate and iodide ions because oxidizing agent, right? So finally if you see, A and D are correct. A and D are correct. So in this particular topic, the most repeated PYQ from this topic, that is based on permanganate as well as manganate. This question you see. Here they ask question format like this. So you can specify it is most repeated question type in potassium dichromate. Okay. Even one more question we studied in other video, D block previous year questions we studied. Their chromyl chloride test also most repeated PYQ. One it is that is chromyl chloride test K2Cr2O7, later we will discuss. So presently about KMnO₄, this particular part is most repeated PYQ. Question format may be any other way, but concept is same. Okay. I hope questions are clear to you. For more updates, follow the channel. Thank you. Thank you for watching.